So we're given another problem here called multiple of index, and we want to return a new array consisting of elements which are multiples of their own index in input array length is greater than 1. So essentially what this is trying to say is we're given an array, and the length of the array will always be greater than 1. Note that it actually doesn't have equals to 1. It's not greater than or equals. It's in fact only greater than 1. So the length of the array will essentially be greater than or equal to 2 in this case, but this is just a masked way of saying that. And given the array, we want to essentially return certain numbers, or rather group those numbers in a new array. And essentially that new array will consist of numbers which are multiples of their own index. So what I mean by this, and let me actually take a screenshot here so that I can zoom in on one of these test cases to really demonstrate what's going on. So we have these elements, and these elements are actually referenced by their index, the count of which actually starts from 0 and moves its way up across the board. And the count actually, given that it begins from 0, we're actually going to start looking at the array from this particular index, which is of course referencing the first element. Although in all cases we don't have to, we could sure enough start from any given element, but usually as we want to search the entire element, we want to start from left to right, if it fits the context of our problem, that is. So here we want to judge the first element, and which of course will judge the ones that follow. But as we're judging the first element, we want to judge whether or not the number, which is the element, is it in fact a multiple of the index? So this is the index, right? This is the index, and then of course we have the element. And is 0 a multiple, or actually is 22 a multiple of 0? And the answer is no. And then as we move forward, I mean, as we traverse the array and as we walk down the array looking at each number, here we judge whether minus 6 is a multiple of 1. And of course we know that all numbers are in fact multiples of 1. And then of course we look at the next and we judge again whether that number is a multiple of essentially whether that number is a multiple of the index, which actually references the element itself. And so we essentially do this for the length of the array, and we return only those numbers which do in fact fit that classification. So I hope that was relatively clear. And what we're going to do is we are going to open IntelliJ, and here I think I have more space to actually explain the nature of this problem and how we would tackle it. First and foremost, a number is so if we had int x is equal to 5 and int y is equal to 25, so essentially we would note that y is a multiple of x if y divided by x is equal to 0. And just sort of making, or if y modulus x is equal to 0. So this is the metric by which we may judge. I think they call it actually there's a formal term for it. I think it's let me actually pull up the formal term. The formal term is a predicate. So we want to have a predicate by which we can judge whether or not the number is in fact a multiple of the other number, which in this case is y a multiple of x. And so this is our metric by which we can judge. That's our predicate, so to speak. So y is a multiple of x if y modulus x is equal to 0. And so we say, okay, if we'll say that we'll have a Boolean statement, Boolean called is multiple, right? And we'll set that equal to false to begin with, only to set that to true in the event that we actually do in fact have a multiple of the other number. So if y modulus x equals 0, then and only then will we set is multiple to true. And so coming out of here and actually printing out is multiple, we should by that logic expect to have true. And of course, if we put 3 here, we know that y is in fact not a multiple of x in this case, because y is 25, x is 3, and so no number any amount of times can be multiplied with 3 to get 25, and so we get false. So this is a successful predicate in the sense that it lets us judge whether or not a number is a multiple of another number. And so we leverage this. And so ideally what we want to do, and this is essentially the array that we're given here. Ideally what we want to do is we want to, so this is where it becomes a little confusing, where it has the potential to become a little confusing. So the series of steps that we want to follow is ultimately our end goal really is to have an array which essentially is populated, right? Populated with only those numbers, only those elements which are a multiple of their index. Now, breaking this into subproblems, we know that we're going to need an array. That's self-explanatory. And in order for an array to exist, we have to declare, and well, not exist, but in order for an array to populate, we need to know its length, right? Because we have an idea of how an array is declared. Int new array equals new int, and then here we actually have to put the length of the array. And so if you think about it, right, so this test case here, it should give me 3 numbers. I think it should give me -6, it should give me 32, right, and it should give me 25. And we understand that the length of our array, the new array that is, should be populated with these numbers. And so the length of the array is just the number of elements which the array consists of. And so the length of the array will essentially be how many numbers there are which meets the classification of the element being in fact a multiple of the index. And so in order to find out the length of the array, we actually need to find out how many elements in the original array actually classify, or actually are how many elements in the array qualify for being a multiple of the index. And so what we're going to do is we're going to essentially have a count, right? Because we want to figure out the length. Ultimately, the goal is to have new array equals new int, and then we're going to put count here because this is the count variable is going to count how many numbers there are which sort of meet that requirement, and then that count will be the length of the array. So in order to actually do this here, so we're going to have int count, and then we're going to iterate for the length of the array, and this is going to be array.length. And we'll increment I by 1 each time so that we can actually look at a new element. And essentially in here, we are going to say if, so this is where we don't have x and y anymore. We have to work with either nums, or actually array of I or I. So array of I is the element, I is the index. And so before we had this understanding that that x is essentially, in this case, in this context, x would be the element, right? And y would be the index. X would be the element and y would be the index. Now, we would want to judge, so the end goal is have an array which is populated with, so we would want to judge is y a multiple of x? In other words, is the element a multiple? Okay, so I think this would be the other way around maybe. So y is the element, so array of I is the element, and then we divide by I, which is the index. So if array of I, let's say modulus I is equal to 0, then we can increment count by 1. So for the first example, you'll see that we're at the 0th index. Array of I is 22, so 22 modulus 0 is it equal to 0. So the idea here is that the first number in the array can never be equal to, the first number in the array can never really be a multiple of 0. because the index which is referencing that element is in fact 0 at all times. And so the first element will never fit this classification. So we in fact start counting from 1. Because we know that the array length is always going to be greater than 1, so it will never be the first element. So we're going to have an array at least of length 2. And so this is, so essentially if any given element, barring the first element, if any given element fits this classification, then we will increment count by 1. So you'll see here that -6 is at the first index, right? And which is of course, in fact, the second index, but since we start our count from 0, it's in fact the first. And so we judge if it's a multiple. So is 6 a multiple of 1? We know that all numbers are in fact multiples of 1. And so it fits this classification, and so we increment count by 1, and then as we move forward, we do this again and again. So now we are able to now bring back what we had before, which is int new array. So now we know that new array dot length, if we wanted to use new array dot length, we know that the new array has a length now, and the length is equal to how many numbers there are which fit the predicate that we had here. And so what we'll do now is we will make another array, and this will iterate again for array.length. We'll increment I by 1 each time. And what we want to do in this case is we essentially want to populate new array with those numbers. So the first part of this was actually finding how many numbers there were which fit the classification of being a multiple of their index. And the second part of this is really trying to understand that now that we have a length for the array, we have the length of the array, we now want to essentially populate that array with those numbers. And so we'd essentially use the same, we'd search the array. That's why we do array.length. We search the array, and essentially what we will do is we'll say, okay, if array of I, and this is the same condition, the same predicate, if array of I modulus I equals 0, then we know the number at any given, on any given iteration is in fact a multiple of their index. And so here, what we'll do here is we would want to populate new array. And what we'll do here is we'll say, okay, I want to start populating from 0. And so we're going to have another essentially a variable which keeps track of the index that we're on for new array, and that will equal wherever that element was found. Okay. And so this allows us to have 2 pointers instead of one. One pointer is keeping track of where we're populating the new array, and the other pointer is keeping track of where that number was found. And then it populates that into new array, that value into new array. And after this requirement is met, and now of course we never want to check the first element because we know that that first element is in fact barred from that classification, from that requirement. And so that's just out of the way. And so now what we can do is we can iterate over new array.length, and we'll increment I each time, and this will essentially allow us to print out the values in new array just to show us that we actually have these 3 numbers here. So let's see what went wrong here. So let's actually first test whether this gives us the count, right? So we'll just say print count, and we'll say that the count is count. And so that we definitely know that there are 3 numbers in this array which fit the classification. So up until here, we seem fine. So we're fine here, right? And then we populate count, sure. And so the problem is more than likely here. So it seems like we start at 1, I is less than array.length. So this is, I guess this is really the problem, because we're saying array, well, okay, array.length, we can say that because we want to iterate over through the entire array. And if array modulus I, right, equals 0, which we know is the correct metric or predicate, then we populate new array starting from 0, and it equals that particular element. But of course, we have to ensure that we start populating the next element, right, in a new array. And so this was really the issue. So now you see it gives us those numbers. So let's go ahead and so this clearly works, right? And it should work for all test cases. So let's go ahead into let's see. Well, we want to go back to training on multiples. And here we'll sort of go over the code one quick time. So what we did in this case was we wanted to count how many such numbers there are, such numbers being elements which are a multiple of I, or of their index. And so we had int count is equal to 0. We had a for loop, int I is equal to 0. I is less than array.length. And we increment I each time. And then, of course, we judge whether the array of I, which is any given element, modulus the index equals to 0. And if, of course, that's the case, then we essentially increment count by 1. And after we come out here, we can then, of course, create a new array of a particular length, which is of count length. And then, of course, we come back into our for loop here. In I is equal to 0, I is less than, again, array.length, because we want to iterate through the entire array. And here, essentially what we'll do here is we're going to start, well, we note that the first number can never be, fit that classification. And so we start from 1. And then of course we use the same metric by which we can judge whether or not it is equal to 0, or whether or not the element is in fact a multiple of the index. And if it is, then we'll populate new array starting at 0, then incrementing each time with that number, if of course it occurs. And so we have to have an index, and then each time this classification is met, we'll increment index by 1, such that when we come back, we'll be able to reference a new element in the array. And after it's all said and done, we'll just return the new array.